Hi, eighth grade. As we talked about yesterday in our Zoom meeting, are going to continue on with Chapter 3. So before we entered this continued learning, we had done Chapter 3, section, the first half, the A section, and we had taken a test. So now we are moving on to Part B of Chapter 3, which mainly focuses on sets. So we talked a little bit about Chapter 3, Part B, while we were doing Part A. One of the ways that we had talked about it already was to talk about the empty set, which is when you are solving out an inequality and there's no possible solution. So you got something like 8 is less than 5, which is not true. When that happens, your solution was an empty set, and we talked about that a little bit. We're going to talk a lot more about sets in Part B of Chapter 3. We're also going to talk about compound inequalities, so a little more sophisticated kind of inequality. And finally, we will end Part B with a section on unions and intersections, which is how two different sets work together. So what I would like you guys to do at home is take out a piece of loose leaf. When we do a new section, I am going to send you pictures of that section so that you have them in case you don't have your book handy. I would like you to take out loose leaf and do a heading and notes just like we do in class. So you can see our heading here is 3-5, working with sets, and we've got 5 vocab words. So what I'd like you to do right now is pause your video and take out that piece of loose leaf, do your heading, do your vocab, and once you're done with that, start the video again. Now that you have your notes taken, or your vocab anyway, I am going to do a brief explanation of these vocab words, and then we'll go through the section. So the first 2 vocab words, roster form and set builder notation, are both ways that you can write the contents of a set. So roster form is essentially a list of all of the elements in a set. If your set is small, say you have 5 items in your set, roster form is fine. If you have a set that maybe it's infinite, maybe it's every whole number greater than 3, something like that, it is literally impossible to write out every element in that set. So you're better off going with set builder notation. Set builder notation will say something like x such that, all real numbers x such that x is greater than 3, and it's a whole number. So you can specify exactly what your set looks like, and that works really well for sets that are infinite. Coming down, we have the empty set. This is the one that we had talked about before, and you might remember me saying you could write this like that, or you can do the little set marks and just leave it empty. So both of those are good ways to say that you have an empty set, meaning nothing is going to work there. Universal set is your biggest set that you have. So say we're talking about real numbers. Our universal set would be all real numbers. So it's the biggest set that you can have. Complement of a set is kind of the opposite of your elements that you've listed in your universal set. So if I have a universal set of all real numbers, I could say I'm going to talk about a subset that is even numbers. So within all real numbers, I have this subgroup of even numbers. I think I may have said that wrong. We have all real numbers, okay? This is all real numbers. Within that, I have a subset that is even numbers. Outside of that circle, my even numbers, I have my odd numbers, okay? So my complement to my even numbers would be my odd numbers. If you flip that around, we could say that complement to the odd numbers is the even numbers. So they work hand in hand with each other to fill your whole universal set. All right, so just a second. All right, so we are going to move on to problem 1 in your book. Problem 1 talks about the difference between roster form and set builder notation. So roster form, again, is just a list of everything in your set. Set builder notation allows you to talk about your set more in words than just the numbers that are in there. So if you're saying something in roster form, we're going to name our set using a capital letter. So say we're going to use T. So we're going to say T is, which is the equals. So you would say this, T is, and then you're going to list out your set. So you use those fancy brackets, and we are going to list all of the elements in our set. So for this one, we're saying 1, 2, 3, 4, 5. So these are the elements in our set. So we say T is 1, 2, 3, 4, 5. If we are going to write the same set in set builder notation, what we're going to do is still call it T. So we still say T is, and then you're going to use your brackets again. And here we are going to say X, all real numbers X, such that. So this, you say all real numbers X. And this line here, you say such that. So it's all real numbers X, such that. And then you're going to say your X again. Oops. And you can specify what X is now. So in this case, we're going to say that X is, I'm going to fit. X is a natural number, and it is, so for the and, we're just going to put a comma. X is less than 6. And we close our bracket. So set builder notation has a lot more parts to it than roster form. Roster form, you just name your set, put an equal sign, you use your brackets, and you just list out the elements of the set. Set builder notation looks a lot more complicated. We still have the name of our set is, which is the equal sign. We still have brackets. It's what's inside the brackets that looks different. You are always going to have this all real numbers X such that. So you're always going to have your variable and then this vertical line and then your variable again. That is consistent in set builder notation. What's over here is a description of what is in your set. So in this case, our set we're talking about is 1, 2, 3, 4, 5, and we can talk about that by saying it is a natural number and it's less than 6. So natural numbers, remember, are your counting numbers. We'll be using those names for sets of numbers in this section. So we'll be talking about natural numbers, we'll be talking about whole numbers, trying to remember how they go. So it's natural, whole, integer, which is brings in your negatives, and then rational, which brings in your fractions and decimals, and then real numbers, which would be something like, let's see, pi. Pi is a real number that is not a rational number. So rational numbers are anything that can be written as a fraction. So even your repeating decimals and your terminating decimals can all be written as a fraction. So they are rational. But anything outside of that is just a real number. Okay, so what I want you to do now is pause the video again and go ahead and try Goddard's 1A and B. Try those, and then I'm going to go over them. So pause your video and try Goddard 1A and B. So Goddard 1 tells us to think about n, which is a set of even natural numbers that are less than or equal to 12. We're to write that in both roster form and set builder notation. So again, both of them are going to start out with the name of your set, which in this case is n. Remember, that's a capital letter for sets. So both roster form and set builder notation start out with that capital N. Roster form then is just going to list all the elements of our set. So we need to put them in a bracket. Natural numbers are counting numbers, so they start at 1, but we're talking about even natural numbers, so we're actually going to start at 2. And we are less than or equal to 12. So that means we need to go the whole way up to 12. So we're going to say 2, 4, 6, 8, 10, 12. Those are all the elements of our set. That's in roster form, where we just list them all out. Now we're going to tackle set builder notation. So again, we start with our capital N, the name of our set. We still have that equal sign, which we say is. And then we're going to have our set builder notation in our brackets. We're going to say x, all real numbers x, such that x is, and we can just explain what these words said. So x is an even number, an even natural number. And we can use inequality symbols and say less than or equal to 12. So I'm going to put a comma between here so that's clear that that's two separate parts. X is an even natural number less than or equal to 12. So that would be your set builder notation. We can even put, I'm going to put an X in here. That looks a little funky with, hang on. I'm going to say X is less than or equal to 12. I like that better. So our set builder notation then is n is all real numbers x such that x is an even natural number and x is less than or equal to 12. That completely explains our roster form and our description of our set that we were supposed to fulfill. So that's the example for problem 1. I am going to move on to problem 2 now. So problem 2 brings us back to what we were doing in part A of chapter 3, which is solving inequalities. So what we're doing here is solving this inequality, and then rather than just say something like, I don't know, x is less than 2, we're going to write that in either roster form or set builder notation. So we're supposed to decide first what is the actual solution to this. So for that, we need to remember how to solve our inequalities, which essentially is the same as if there was an equal sign here. The difference is you need to remember if you are multiplying or dividing both sides of your inequality by a negative number, you have to flip that inequality. So when we realize our coefficient here is -5, we need to remember that we have to flip that inequality. So when we divide over here, these cancel out. I flip my inequality, and this would be -2. So we know that our solution here is x is greater than or equal to -2. Your job now is to write that in set builder notation. So we're going to say, all round numbers x such that x, and we can just say is greater than or equal to -2. All round numbers x such that x is greater than or equal to -2. That's enough for this solution. So that is how you would write this in set builder notation. Think about trying to write that in roster form. So if x is greater than or equal to -2, we would start with -2, and then everything bigger than that, which we can't really list out because you're not saying whole numbers, you're just saying everything bigger than -2. So really this is impossible to do. You can't list everything that's bigger than -2. You would have to say, of course -1 is bigger than -2, but what about -1.999999 and -1.99998 and so on and so forth. It's going to go on and on forever. So when you have those infinite sets, it really is much easier to write it in set builder notation. Go ahead and try got it 2, and then I'll be back to solve that. So again, we're given an inequality and we're asked to solve that out and then write the answer in set builder notation. So the first thing we would have to do here is subtract 9 from both sides. Don't forget that that subtraction sign sticks with the 4n, so we have -4n is greater than, ooh, I'm having a little brain fart here. Oh my goodness. So 20 would be 12, right? Yeah. So now we have -4n is greater than 12. Remember, we are about to divide by a negative number, so that means we gotta flip our inequality. So if we're dividing by -4, we're going to have those cancel out so that we just have n. Gotta remember to flip your inequality. And if I'm dividing over here, positive divided by negative is negative. 12 divided by 4 is 3. So here's our solution, and we're now going to write that in set builder notation. So I'm going to say all round numbers n, because our variable is n here. So all round numbers n such that n is less than negative 3. So before, in part A of this chapter, we were solving this out and we were just getting this part. So all we're doing is adding that set builder notation around it with our brackets and then all round numbers x or n such that n, and you say what your answer is. So we have all round numbers n such that n is less than negative 3. 3 is about listing out all of the subsets for a set. So when you do this, obviously we have subsets that are 3, 4, and 5. A couple not so obvious subsets are with every set, one of your subsets is actually the empty set. So I highly recommend you list the empty set first because that is an easy one to forget. Another subset that's a little bit weird is the actual set itself. So if we say that our set is 3, 4, and 5, one of its subsets is also 3, 4, and 5. So I highly recommend you list that empty set and also the universal set first. The next thing that you're going to do is break down your subset. So when you do this, you want to make sure that you have all combinations of just one element. So we're going to list each element separately and say, okay, well, 3 is a subset of 3, 4, 5. 4 is also a subset, and 5 is also a subset. Ooh, that's kind of funky. You guys will be impressed by how quickly you get good at writing our little set symbols. All right, so we have our empty set, we have our universal set, and we have subsets that each have one element in. When our universal set has 3 elements, the only other option is to list out our subsets that have 2 elements in the subset. So we need to figure out what all of those combinations are. So we're going to say 3 and 4, 4 and 5, and there's one more. Take a second, think about it, see if you can decide what it would be. So hopefully you came up with 3, 5. When we have 3 elements in our universal set, this is a complete list of all of our subsets. We have the empty set, we have the universal set, we have 1 element in each subset and 2 elements in each subset. So this again is a complete list of how many options you should have, how many subsets you should have if your universal set has 3 elements. So we have 1, 2, 3, 4, 5, 6, 7, 8 subsets in total. That's going to happen every time you start out with 3 elements in your universal set. If we bump that up to 4 elements, we would then have these 8, and then we would have additional elements, or I'm sorry, additional subsets that would have 3 elements in them. So if I increase this to 4 elements in my universal set, I'm still going to have all of these. Oh, and I need to add a couple more, don't I? I need to add 6 here, 6 here, And then in my 2, I'm also going to have more. So I still have 3, 4, 4, 5, 3, 5. I need to add, actually, I'm going to start these over because I like to do them in a specific way. So I'm going to do 3, 4, and then I'm going to add everything with 3 at the beginning. So I would do 3, 5, and then 3, 6. And then I could think about, well, what if I put 4 as my first? I already have 3, 4, so I would need 4, 5, and 4, 6. And then I'm going to put 5 first, which I already have 3, 5, I already have 4, 5, but I need 5, 6. So this should be all of our subsets with 2 elements in them. And now I need to think about those subsets with 3 elements in them. So I would do 3, 4, 5, 3, 5, 6, 3, 4, 5, 3, 5, 6. I need 3, 4, 6. You can see these are going to get exponentially bigger in the amount of subsets that you have. So we have 3, 4, 5, 3, 5, 6, 3, 4, 6. So I believe that's everything with 3 at the beginning. So if we then put 4 at the beginning, we would have 4, 5, 6. And that's the only difference from 3, 4, 5, I believe. I think that might be all of them. 3, 5, 6. 4, 5, 6. Yep, I believe that's it. So we now have, how many? We have our empty set, our null set, our universal set. So that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 subsets we have now, which obviously is a big increase from the 8 that we had when we had 3 elements. So every time you add another element to your universal set, you're going to add a whole nother layer of subsets that you have to come up with. Your book isn't going to give you, I don't believe, anything more than 4 elements in a subset because, again, it would get a little hard to work that through. So we have one more problem, which is problem 4. Problem 4 is the one that is talking about complements of your universal set. So the complement is everything that's not in the subset that you were talking about, but is in the universal set. So they show us our universal sets showing a box. So that U signifies that everything in this box is going to be our universal set. For this example, they're talking about chess pieces and how chess pieces move. So they give you a nice visual explanation in your book on how those chess pieces all can move legally, and that is on page 212 in your book. And they're saying that all chess pieces are our universal set. And then they want us to come up with a subset in here that they've named A. So this is subset A. Everything outside of subset A would be A prime. So that is going to be our complement of set A. So in set A, they have asked us to put all the chess pieces that can move side to side. So which chess pieces can do this? So that would be your king, your queen, king, your queen, and your rook can all move side to side. So when, gotta say, I don't think I ever knew the actual name for a rook, which is the chess piece that looks like this. I always think I called that tower, but it's a rook. See what you learn? All right, so that is our subset. Those are our pieces that can move side to side. Those are the only chess pieces that can move side to side. King, the queen, and the rook. Our complement to that set is all of the other pieces in chess that cannot move side to side. So that would be our bishop, our knight, and our pawn. So our complement, or A prime, would be bishop, knight, and pawn. Those are the chess pieces that cannot move side to side. Essentially, that's all you're being asked to do here, is to come up with these two lists. So we can now say in roster form that A, the pieces that can move side to side, is king, queen, and rook. And we can say that A prime, which is the complement or everything else in our universal set, which in this case is our chess pieces, is equal to bishop, knight, and pawn. So you're listing those out in roster form. If you wanted to list these in set builder notation, it's a little awkward because you're still just listing. At the beginning, you would add whatever variable you want to use. Let's use C for chess, or P for pieces maybe. Use P. So P is such that P equals, and then you would list. So set builder notation really isn't great here. Again, set builder notation is really helpful when you have an infinite number of numbers in your solution or in your set. So here, roster form works better, where we're just listing out our set members. And this is what it would look like. Go ahead, pause the video, do got it 4. So got it 4 is about the months of the year. And they've told us then that our universal set, or our complete set, is all of the months of the year, which there are 12. So our universal set is going to have the 12 months of the year in it. Our subset that they want us to do, which they have called A, is going to be the months with 31 days. So all the months that have 31 days are going to go here, and then our complementary set would be the months that do not have 31 days, which would be the months with 30, and then February, the odd duck that doesn't have 30 or 31. When you list out your months that have 31 days, this makes me a little sad that we're not together, because this is the point in the year that I always show everybody my knuckles trick, and we're not together. So I don't know how well this is going to show, because I don't know how well you can see my knuckles. But when I was in elementary school, we learned a handy dandy way to tell which months have 31 days. So if you start with a knuckle and say that's January, and then in between is February, March, April, May, June, July, and I've run out, so I have to go knuckle again, August, September, October, November, December. So your knuckle months are the ones with 31 days. So January has 31, February does not. March has 31, April does not. May has 31, June does not. July and August both have 31. September does not. October has 31, November does not, and December has 31. I hope I have just blown your minds. When we do this, then we can list out our months that have 31 days. So January does, I'm going to go ahead and do this one at the same time. February does not. March, April, May, June, July, and August both do, and I've run out of room. September, I don't know what to do now. I can't just slide it like I do on my smartboard. August, September, we'll just do this. November, wait, I skipped October, sorry. October, November goes down here, and December goes up here. Sorry, that ended up being a mess. So our subset A of all of the months that have 31 days is January, March, May, July, August, October, and December. And our A prime is February, April, June, September, and November. And remember your knuckles, January. Excuse me. Whew. January, February, March, April, May, June, July, August, September, October, November, December. Ta-da! Alright, so that is all I have for, oh, actually, I realized that I forgot the got it for problem 3. So if you want to pause your video and go back and do got it 3. Sorry, this is allergies, by the way, not corona. I'm good. I'm really good. So we're going to do got it 3A and B. If you would go ahead, pause your video, do those got it's, and going back to got it 3, we have A and we have B. A is set P, which only has the elements A and B in our universal set. That means that our subset list is going to be pretty short. So we always are going to start out with the empty set and the universal set. So I have both of those out of the way. And then with this one, the only other option I have is each set or each element by itself. So I have our listing where we have one element in each set, and that's it. That is our list of subsets. Going over to got it 3B, we have 3 elements in our universal set, which means we know that we should end up with 8 subsets. So again, we're going to start with the empty set or the null set, and then our universal set, and then I need to list each element by itself. Oops. And I'm going to list 2 elements together. So we have A and B, B and C, and then A and C. That is our 8 subsets for our universal set A, B, and C. So now I am done with all of the examples and got it's, and I would like you guys to try some of these problems. So if you would flip to page 213, I would like you to do numbers 9 through 24. So you are doing 9 to 24 by 3s. And that is on pages 213 to 214. And I would really hope that you guys will watch this video today, do those problems, and get them turned into me hopefully tonight, if not sometime tomorrow morning. And then tomorrow afternoon I will post a video going over these answers. So when you have a video to watch like this, obviously this turned into quite a lengthy video. So what I would suggest is on days when you are doing a new lesson, you don't do Get More Math. If you've already done it today, good for you. If not, that's okay. You can skip today. If you did do it today, go ahead and skip tomorrow and just watch the video where I go over the answers tomorrow. So that'll be it for this week. We will do this lesson and you'll do some problems, which are these, and then I will post a video going over those answers, and that's it. So if you could go on Get More Math twice this week, do this assignment, and then watch me go over the answers for this assignment, you will be set for math this week. And we will get back together. We have a Zoom meeting on the 20th. And that Zoom meeting will be from 1:30 to 2 o'clock on the 20th. And I will send you out that invitation no later than the 19th so that you have it the day before. And we will probably start up with a new lesson then on 3-6. So I will see you guys after Easter break. And I hope that y'all have a blessed Easter.